Hi friends, welcome to Tutorials Point. In this video we are going to understand operations management and under that product design. These are all the various topics that we will be going through. The purpose, why exactly we need product design, and then customer specific requirements capturing, drawing, engineering specification, how these things are going to be derived from the customer specific requirements that has been already captured. First, we need to understand the purpose of product design itself. So, whatever that we are going to understand from our customer, we need to transfer that into a tangible product or a services. So, then only the customer is going to buy our product or services. So, for that there are various things that can be done which we are going to see in the next coming slides. So, in CSR capturing, that means to say customer specific requirements capturing, we have to understand the fit requirements, form, function requirements, durability means how long it is to be used for how many years, and then reliability, what are all the extra load when it is going to be put on the product it has to sustain. Okay, so all these things makes a lot of sense if we fulfill all these kind of requirements and then we are going to transfer into a tangible product, then it makes a lot of sense. Maybe if you want to talk about the durability, one example, maybe a product has been designed to last 10 years and it is not coming even crossing 7 years. That means to say we are having an issue in the durability. When we talk about the reliability, consider that a product has been designed to take a load of 40 people and it is not even able to take a load of 30-35 people. That means to say this is absolutely not durable itself and reliable also. So when we talk about all these things, it makes a lot of sense to capture requirements from our customer and then transfer into tangible products and also the services. So in drawing it looks something like this, and here we need to concentrate on certain specifics like geometric dimension and tolerancing, because we need to always optimize this particular tolerance, because when we have the various child parts that are going in the same assembly, not all the child parts will be having a same kind of an tolerance, or not all the things will be having in the upper specification or in the lower specification. So we have to take into consideration of the statistical tolerancing when we are doing the geometric dimension and tolerancing, and what are the identification that needs to be there on the product. Also we need to be very clear and what is the location on the product or on the assembly where it's going to come. With respect to the identification also needs to be very clear, and it can change from country to country based on their culture and based on the language that they are very much used to that. And bill of materials also plays a very important role, because based on that specific bill of material itself we are going to have this particular product and the assembly. So we should not deviate this bill of material. Once we deviate, then there is going to be a lot of problem in the functioning and operation of this particular product or the assembly itself. When we talk about the engineering specification, we need to understand the specifications for the testing or validation where a lot of extra load is going to be put. The load can be thermal load, chemical load, or a temperature load, these kind of things. And also we need to understand the requirements from simulation point of view, because we need to understand that when we really go into a testing or validation, it takes a lot of cost. That means to say there is a lot of pressure on the bottom line. So many things we can easily do that in the simulation itself. That is a very cost efficient solution, and many of the problems up to around about 70 to 80% we can easily detect at the design stage itself. And finally, we should not forget to have the application requirements. This plays a very important role to give to the customer, so to train the customer. So whenever you give a product or a service, you need to also give with the application specification so that your customer understands it exactly how to use it and not to abuse it. And later all these problems of miscommunication and raising a complaint which is not a complaint, all these things can be easily resolved. Now we will understand the DFMA, that is means to say design for manufacturing and assembly, and we need to consider the design for manufacturability and also design for assembly. So in design for manufacturer, we have to understand that it's not only the product design, but when it goes into the process, we have to make it as easy as possible from ergonomics front and also from the productivity front. That means to say it's not only the quality aspect, but it is also the quantity aspect. So operator has to feel very easy to manufacture these kind of components, and operator also has to find it very easy when he is trying to do an assembly of this particular operations. So when we put both the things together, then it becomes a design for manufacturing and assembly. So it's a concept of DFMA, which we have to consider when we are doing the process design, which is derived after the product design step. To conclude, with respect to the product design, we understood how to capture the customer specific requirements and how we are going to transfer that into tangible products and services, considering fit, form, function, durability and reliability. And also we understood the concept of DFMA. That's all in this video. Thank you so much.